Welcome to week 12, question 1. In this lesson, we're going to be looking at integration, which is that operation that reverses taking a derivative. So in these cases, we'd be given a derivative, and we're to find the original function. But before we start that, I want to just have you think about integration and differentiation and see some of the things that we need to consider. So the first thing I'm going to do is write a function, say 3x squared plus 2x minus 17, and I'm going to ask what the derivative would be. And the derivative, is 6x plus 2. Then I might have a function like this. And I would say, what is the derivative of this function? And you might say 6x plus 2. Whoops. And the derivative of this function would be 6x plus 2. Okay, so if we look at this, we might be scratching our heads wondering, why do we have three very different functions which all have the same derivative of 6x plus 2? And we'll note that the difference in the functions is this constant, a constant term, which is different for each function, but because the derivative of a constant is 0, you can see that there's no remnant of it in the derivative. So when we're going from the derivative back to the original function, we need to consider that there was something there before, perhaps, or not. There was some constant there before. And we have to look for information in the question in order to determine what was that constant in the original function. Okay? So in question 1, we've been given a function which we are told is a rate of change function. So its imports from country A have changed at a rate of. So remember our word wall, we had the word slope, which meant derivative, which meant rate of change, which meant depreciation, and so on and so forth. So those were all words that meant derivative. And we're given this function here, which, if it is the rate of change function, that means it's the derivative. And it says that x equals 0 for 2000. And we're given some information here that we might want to just underline as well. Country A imported $222.94 billion worth of goods in 2001. Okay, so it says in A, find a function giving the value of imports X years after 2000. So what that's suggesting is that we need to find the integral, or need to go backwards from the derivative. Okay, so we have to remember our derivative rules. So here we have 3 terms, and we have a simple power rule. And we're going to just keep that over there. So x to the n, the derivative was is nx to the n minus 1. So then we can consider, when we're integrating, we're actually going the other way. So we have an n x to the n minus 1, and we want to find what the x to the n term was. Okay, so we have 0.18x squared. So in the original function, it was an x cubed, and we multiplied whatever was in the front here by 3, right? So now we are going to divide by 3. right? Then we have 0.24x, so in the original function it was an x squared, and instead of multiplying by 2 as we did to find the derivative, we're going to divide by 2, reversing that. And plus 11.76, there used to be an x, and so we're putting it back there. Now you'll recall that we still need to have a constant, because we don't know, was there a constant there or not? And we look back to the question to see if there's any information to help us, and that's when we use this information. But first we should tidy up the equation a little bit, complete our divisions. So this would be 0.06 x cubed plus 0.12 x squared plus 11.76 x plus c. Okay, so we're going to be substituting g at 1 will be 222.94 is equal to 0.061 cubed plus 0.121 squared plus 11.76 times 1 plus c. And we're going to complete these terms and then solve for c, and we find that c is 211. So now our complete function g at x would be 0.06 x cubed plus 0.12 x squared plus 11.76 x plus 211. So now we can use this function to find the value of imports of country A in years after 2000. And so in B, you can see that we're asked to find the value of imports in 2003. So let's complete that on the next page. Here's the function that we found from the derivative function, and as I said, the question B asks for imports in 2003, so we would substitute x is 3 into this function and find out what the imports are in that year. And when we solve for this, we find that our imports were 249.98, and that was in billions.